Hello. In this module, we are going to talk about the R packages. Now, R packages are the set of predefined functions, objects, and documentation. Now, these R packages extend the functionality of R. And who write these packages? Well, anyone can write this package. There are lots of researchers, statisticians, academicians who are using the R. They design the tool so that people can analyze the data, and they release the tools that they have built in the form of packages. Now you can find all these packages on the websites, on the CRAN website. Remember, CRAN is the website that hosts R. So we have downloaded the R from the CRAN website, right? So on the same website you can find all the packages that have been developed so far. In explaining the R packages, I use the analogy of mobile phone and its app. When you go and purchase the mobile phone, it comes with the basic functionalities. You can attend the calls, right? You can make the calls, you can text message, and perhaps you can click the photographs. But beyond that, if you want to increase the functionality of the mobile, then you need to install the apps in it, right? For example, you click the photo and you want to upload the photo on your Instagram account. Then first what you have to do, you have to install the Instagram app on your mobile, and then you can do that. So in a similar way, when you install the R first for the first time, it comes with a basic functionality. But beyond that, if you want to use the R for a specific analysis, for example, if you want to use the R to analyze the time series data, then you need a specific functions who will analyze the time series data. And those specific functions who can analyze the time series data are bundled together in the form of package. So what you have to do, you have to go to the CRAN website and install those specific packages which are used to analyze the time series data. If you go to the CRAN website, then you can see thousands of packages. Each package comes with its own unique functionality. For example, there is a package called ggplot2, which is used for data visualization, a package called dplyr, which is used for data wrangling, a package called lubredet, which is used to analyze the time series data, and there are many more packages. So as I said before, the strength of R lies in its packages. Now let us see how we can install the packages in R. So I have opened the CRAN website. It's the same website that hosts R, and here you can see the packages. Go to the packages, go to the table of available packages, and it will give you the entire list of the packages that have been released by the R community. So actually, to install the package in our environment, you don't have to go to the CRAN website. There is another way of installing. So let me show you how you can able to install the R packages using the RStudio environment. So I opened the RStudio. Now remember, in the last session we saw how we can able to write the R script, right? So in this case also we are going to use the R script. So for that I go to the file, new file, and R script. So I open the R script. So now I have opened the R script, and in the R script I am going to show you how you can able to install the packages. Now in order to install the package, you need to use the function install.packages, and in the function you can pass on the name of the package as the argument. Now please ensure that you write the name of the package within inverted quotes. So I want to install ggplot2 package, so I am writing ggplot2 quote unquote, and then I will run the command. Now as you can see that R is now installing the ggplot2 package. So what R is doing, R is actually communicating to the host server, communicating to the CRAN server, and it's fetching the data from the CRAN server related to ggplot2 package, and it is storing all the data on your local hard disk. So you can see many instructions given by the R. So these are the typical instructions that you see when you install the package for the first time. So let it get installed. Yeah, now you can see that ggplot2 package is successfully installed. So you can see the message, it's got successfully installed. Now remember one thing which is very important. You will have to install the package only once. Okay, it's like mobile phone app. When you want to install the app, you install only once, unless you want to upgrade the app to the latest version, right? So installation is only once, installation of the package is only once. But when you open the R session, when you open the RStudio session, every time you open the RStudio session, you need to load the package. Okay, you need to load the package. Now let me show you, if you don't load the package, what is the warning that R gives you. Now one of the command that I will be using is qplot. Qplot is quick plot. It's one of the function in ggplot2 package. So let me use that function. Now remember, ggplot2 now got installed on your hardware, on your hard disk, on your computer. Now I will use qplot function. So let us see what happens if I write qplot function. So I've written the qplot function and I'm running this command. Can you see the error here? It says that qplot function could not be found out. Why it is so? Because we have installed the ggplot2 package, but we have not loaded the package in the RStudio environment. So in order to load the package in RStudio environment, you have to use library function. So, library ggplot2, run. Now you can see that this package is built. So library ggplot2. Now once I load the package in the RStudio environment, RStudio session, then perhaps I can able to use this qplot function. Now let me show you how this qplot function looks like. So for that I need some data. So I am entering some data here. I am entering one-dimensional array, a vector. Okay. So I have created a one-dimensional vector. Now you must be wondering, what is this C? What is this small letter c? Small letter c stands for concatenate. Whenever you want to bind the one-dimensional vector together, so you use concatenate. So in this vector I have some negative numbers, I have 0 and some positive numbers. So I am binding them together and forming a vector, one-dimensional vector. So for that you use C or concatenate. So y is simply the x cube, and now I will use the qplot function, x comma y. Now let us see how the plot looks like. Now can you see this plot? This is how the plot looks like. So you can see this is called as a scatter plot. Scatter plot is used to find out the relationship between the two variables x and y. Now in this case you can see that the relation is non-linear. Okay, so Scatter plot is most widely used to find out the relationship between the two variables. Scatter plot gives you the relationship between the two variables. But if I want to check the distribution of a single variable, then there is another plot which is called as histogram. Now you can use the qplot function to plot the histogram. In this case, the single variable, which is called x, which is a one-dimensional vector, will be the first argument, and the second argument is something called as a bin width. Now what is this bin width? Bin width is nothing but the histogram divides the x-axis into equal number of bins, and the width of the bin can be specified with the help of bin width. Now let us see how we can able to plot the histogram in R. So let me open the R. Now as you can see, we are using the ggplot2 package which we have already installed. We have loaded the package with the help of library function, and now this is the one-dimensional vector x that I've created, and this is the qplot function which we are going to use to plot the histogram. This is the bin width argument that I was discussing about. So now let's execute this qplot function command and let's check how the histogram looks like. So as you can see, this is how the histogram looks like. So this is the overall distribution of the vector x. Now as you can observe in this histogram, there is only one value which is appearing between the interval 1 and 2, and that one value is represented by the bar of height 1. Similarly, between the interval 2 and 3, there are 3 values appearing. So the histogram will show a bar of height 3 between the interval 2 and 3. Similarly, between the interval 3 and 4, there are 2 values appearing, and that's why you can see the bar of height 2 represented between the interval 3 and 4. So this is how the histogram is interpreted. Now we saw how the qplot function can be used to plot the histogram. Now let us create a small experiment. You remember the roll function that we constructed, which gives us the sum of the pair of 2 dice. Now if I throw the pair of dice many times, okay, if I throw the pair of dice, if I roll the pair of dice many times, then how the histogram of that experiment would look like. So this is how the histogram would look like. But in order to get the histogram of this shape, you need to run the experiment many times. So you have to roll the experiment many times. And if you roll the dice many times and plot the histogram, then it will show you how often each sum is appeared. Now as you can see that sum 7 has appeared many times. That's quite logical, because in order to get the sum 7, you can use the combination of all the numbers that the 2 die will produce, right? You can have a combination of 6 1, 5 2, 4 3. So you can see that all the 6 numbers are appearing in the combination to get the sum 7. And because all the 6 numbers are appearing, there is a high probable possibility that the sum will be turned, that the sum 7 will be turned when you roll the die. Now in contrast to 12 or 2, the possibilities are very few, because in order to get 12, we need to have 2 pair of 6, right? You need to have a pair of 6, and getting the pair of 6, the possibility of getting the pair of 6 is very low as compared to possibility of getting the 7, and that's why you can see the number 12 and number 2 are appearing at the far end of the histogram with the lowest number of frequency. Now let's check how we can able to roll the dice many times. So for that we need to use replicate function. Now replicate function has two arguments. The first argument is the number of times you want to repeat the command, and the second argument is the command itself that you want to repeat. Now in our case we want to repeat the roll function, because roll function is going to give us the sum of the dice, and the second argument will be the roll function, and the first argument will be the number of repetitions that we want roll to get executed. So let's see how we can do this in R. Now here you can see I've generated the roll function, this we saw in our earlier module, and then I've used replicate function. Replicate function has two arguments. The first argument is the number of times you want the command to be repeated, and the second argument is the command itself. Now in this case we are going to repeat the roll function. Now what this replicate will do, replicate will roll this, replicate will repeat the roll function 10 number of times, and every time it repeats it will get the sum of the pair of dice, and it will store the sum of the pair of dice in number rolls object. So this number rolls object will be a vector of length 10, and I am now using the qplot function. I am using this vector number rolls as my x argument, and I am using bin width equal to 1. Now let's execute this code and let's see how the histogram looks like. So this is how the histogram looks like. Now this histogram doesn't look like a pattern that we saw, right? This is because there is too much of randomness, and when you have too much of randomness, then only way of getting some kind of a pattern out of this randomness is to repeat the experiment for many more times, right? Then you are going to get some pattern out of it. So what we are going to do now, we are going to repeat this experiment for 10,000 times. So let me now close this figure and let me change from 10 to 10,000 times. Okay, now let's see how the histogram looks like. Yeah, here we go. Now you can able to see that there is a pattern in the histogram. This pattern is called as a normal curve. So this is a typical normal curve, a bell-shaped curve, or Gaussian distribution it is called as. And you can see that number 7 is appearing highest, and number 1 and number 12 are appearing lowest. But remember, we could able to generate this kind of a pattern because we executed the replicate command 10,000 times. I'm sorry, we could able to execute roll function 10,000 times. Now let us extend our discussion further. Now the pattern that we saw looks like we have a fair die. That means each number has an equal probability of getting selected. Now what if I make this die unfair? That means instead of the probability of 1/6 for any of one number, if I increase the probability to 3, for example for number 6, if the die is fair, then my probability of number 6 getting selected is 1/6. But if I want to make it unfair, that means I am now giving more weightage for number 6 to get selected than other numbers. So I am giving this more weightage by increasing the probability of number 6 getting selected. So from 1/6 I am now increasing the probability to 3/8, and because the sum of the probability has to be 1, the other numbers the probability becomes 1/8, right? Now let us check how our histogram would look like with these weighted probabilities as an input to the roll function. Now this is the same roll function that we constructed, but there is a small change that I've done in this sample function. Now what is that change? I've introduced another argument called prob. Prob is probability. Now I am telling the sample function is that you assign the probability for each number in the die object as mentioned in this probability vector. So for example, from numbers 1 to 5 they will be assigned probability 1/8, and number 6 will be assigned the probability 3/8. Because we want to weigh the die more towards number 6, that's why we are now assigning more probability to number 6, and that is what been replicated with the help of this probability argument. Right now, if I run this command, let's see how the histogram looks like. Now as you can see in this histogram, the possibility of getting number 12 is increased. And why it is increased? Because the die is more biased towards number 6. That means any combination with a 6 in it will occur more number of times than any combination without a 6, and that is what exactly can be seen in this histogram. So this is how we can able to differentiate between a fair die and unfair die. I hope this histogram concept is clear to you. I hope this qplot function, which is a part of ggplot2 package, is also clear to you. Now let's move on and explore how we can use the help command to find out more about the functions and R commands. We have come to the last leg of the session. We started the session by describing what the R packages are, how we can able to load the R package in RStudio environment. Remember, we used two functions. First one is install packages, which installs the R package in our environment from the CRAN website, and second is a library function, which is used to load the package in RStudio session. Remember, you need to install the package only once, but every time you open the RStudio session, you need to load the package from that session. Then we installed ggplot2 function. Then we installed ggplot2 package. ggplot2 package is a visualization package which is used for plotting various graphs and charts in R. Then we use qplot function. With the help of qplot function, we could able to generate two visualizations. The first one is a scatter plot, which tells us the relationship between the two variables, and second one is a histogram, which tells us the distribution of a single numeric variable. Now we are going to quickly see how to use the help page in R. See, there are more than 10,000 functions in R, and it would be mammoth task to remember those functions and to learn how to use those functions. So, and it's simply not possible. So the R, when you install R for the first time, it comes with its own help page, and also whenever you install the new package in the R environment, the package also comes with its own help page. So help page is one of the most important document that you will find in R environment. Now how you can able to use the help page. Now let's see how we can able to use the help page written for the sample function. Let's open the R now. So this is my R session. Now if you want to seek the help of a particular function, then what you have to do, you have to simply type in question mark followed by the name of the function. In this case, I want the help. I want to see the help for the sample function. Then I put in question mark followed by the name of the function, and then I run this command. Now once I run this command, then you can see that the help page pops up at the bottom right pane of RStudio. Now if you want to open this help page in a separate window, then you can simply click on this showing new window button, and then it will open the help document in separate window. Now let's see what this help document is all about. So it starts with a description, what this function is, basically what's the use of this function, then how you can able to use the function. Basically it tells you how you can able to use the function. Then it goes on telling you what are the various types of arguments that you need to pass on to this function. Some arguments will be by default and some arguments you need to pass on to the function. So all these things are elaborated under argument section. Then it gives you the details. Now this detail section gives you a thorough understanding of how you can able to use the function and how that particular function is constructed and what is the logic that goes behind building that function. Then it gives you the value. The value is simply the output of that particular function, references, and for me one of the important part of this help page, if you scroll down right to the bottom, you will find the examples, how exactly this function you are going to use in your R code. So if you go through the example, if you run this example, then you will find out how exactly this function is working. Now suppose that you want to look up the help page for the function, but you actually could not able to remember the name of the function. So simply what you have to do, you have to search that function with the help of keyword. Okay, so how you can do that? It's simple. You can type in 2 question marks in this case and followed by a keyword. For example, I want to find out some function which is related to the log argument, so I will simply put in 2 question mark and the log as a keyword, and then I run this, and R will give me the entire list of functions wherein this keyword log is used. So here we go, and with this entire list where the log is used in some way or the other. Right, 2 question mark followed by the keyword. So this is about the help page which is built into the R. But you know, R has a very powerful and vibrant community. The community consists of academicians, statisticians, programmers, researchers. They write the packages, they write the functions, and then they release the packages and functions for everyone to use. Now you can seek the help of all those people through another platform. That another platform is called as a Stack Overflow. Now Stack Overflow is a platform created for programmers to answer the questions, and depending upon the use of that particular question, each question is ranked. Okay, so now let me show you how the Stack Overflow website looks like. So this is how the Stack Overflow website looks like. You have to simply type in stackoverflow.com, then you will come to this web page, and here in the search you can simply type in the question that you have. For example, if I want to seek the help related to the sample function, then I will put in sample function in R, for example, and then I will search it. Yeah, so here we go. So here you can get all the various so here you can get the log of entire discussions that are happening around sample function, and there are on Stack Overflow itself you will find there are around 30,000 questions related to R which have already been answered. Well, there are more than 30,000 I should say, and there is a high possibility that your question has already been answered by someone. So before you pose the question, please check whether the question has already been attended by someone. There are high chances that you will get the answer. So that's it. That's all about the help page which is there in R. It's very useful functionality, and also you can now able to ask the questions on the Stack Overflow, which is also a very, very powerful platform to ask the questions and seek answers related to our language.